When people ask me why I decided to learn Go, I usually tell them that I had this project that involved multiple programming languages, and I had a command line client that was written in Ruby, and this meant that the Haskell programmers had to have this entire Ruby environment set up on their machine just to do Haskell stuff. And that was kind of silly and a real pain in the ass. And so Go solved this. Now, all of those things are true, but they are not actually the reason that I decided to learn Go. I decided to learn Go because I was at a conference and I met Andrew Durand, and we had a great conversation, and I was like, I'm gonna learn Go. It's gonna be amazing. Somehow, I equated learning Go with having great conversations with interesting people. And it worked. Here we all are. At last year's GopherCon, in his closing keynote, Russ Cox said that for Go to be successful, we need everyone's help, and everyone isn't here. Which brings me back to the question of why people choose to learn Go. It turns out the initial decision is not the most important variable. Once you decide to learn something, you have to actually start. And once you've started, unless you have some really powerful habits in place, you have to keep deciding not to stop. Your reasons to keep putting in the effort have to be stronger than the reasons to quit, which is a somewhat roundabout way of saying that you have to be motivated. If everyone who decided to learn Go were able to maintain their motivation until they were proficient in the language, we'd likely see a pretty dramatic increase in the size of the Go community. So this is an optimization problem. Now, I admit that it's kind of a problematic optimization problem in that motivation is not typically something that we see as a system with inputs and outputs that we can affect. People are motivated or they're not. Their motivation is weak or it's strong. The internet is full of advice about how to increase motivation. You'll see things like, think about who inspires you, or seek environments that make you creative, or find like-minded friends. Now, it turns out, science knows a lot more about motivation than life coaches do. According to science, there are at least 3 independent variables that affect motivation, and these can all be addressed individually. The first is subjective value. It helps to believe that the goal is worth working towards. The second is your expectations of success. You'll be much more motivated to reach a goal that you believe is achievable. And the third variable that affects motivation is environment. A supportive environment is going to be more motivating than a hostile one. A deficiency in any of these things is going to make it much less likely that you'll be able to follow through. And if you think that the goal is achievable, but you don't see the point of it, you'll be apathetic about the whole thing. If you think it's valuable, but impossible for you to achieve, you'll be despondent and unlikely to try very hard. If you think it's both valuable and achievable, but the environment is hostile, then you need to spend a huge amount of cognitive resources every single day just deciding not to quit. When we look at the people who are interested in Go, but who run out of motivation before they've learned it, these are the 3 dimensions that we can optimize: subjective value, expectancies regarding success, and environment. I think that in terms of value, Go is already doing a great job. If you're interested in Go, if you're interested in the types of problems that Go solves, there are plenty of reasons to choose to learn the language. And I think that people, for the most part, are aware of these reasons. So I'm not going to talk about this today. Environment is complicated and subtle, and it involves squishy things like feelings and psychology. And there are others in this community who are far more qualified to address this than I am, so I'm also not going to talk about this today. So given that a person has decided that there is some subjective value to learning Go, and assuming that they have found the environment to be, at the very least, mildly supportive, the thing that is going to make or break their motivation is whether or not they think that they can successfully learn the language. And there are 3 aspects to this. First, you have to have some sort of actionable plan for reaching your goal. Once you have that, you need to believe that the steps defined in that plan will actually work. And finally, you have to believe that you personally can perform those steps. If you ask for recommendations about how to learn Go, overwhelmingly, you'll be given advice that boils down to something like this. First, do the Go tour, then read the language spec, and then write a lot of code. I'd like to look at the ways in which this might fail to motivate someone as they embark on learning Go. So the Go tour is delightful. It's approachable, it's fun, it's interactive, it provides lots and lots of small steps, which sets people up for lots and lots of small wins. So what could possibly go wrong? Well, not much, actually. The worst thing you might stumble into is a slide that's a little bit confusing. But if you already know how to program in some other language, the tour is a phenomenal first step. There is one caveat. At the moment, knowing how to program is generally considered a prerequisite for learning Go. I think Go would make a great first language. I actually think that Go would probably be better for teaching programming than some of the languages that are currently widely in use because Go has such a small syntax, the language is consistent, it doesn't encourage magical thinking, and it has a compiler. There is strong anecdotal evidence that a determined, self-directed learner can learn programming using Go, but we don't have many resources available that are appropriate for non-programmers. And I'm not sure that we're in a very good position to create any right now. The Go community has an overwhelmingly large proportion of people who have deep programming expertise. Now, I know that sounds like a good thing, but experts have a hard time explaining what they do or how they know. They're completely unaware of the shortcuts that they take, the steps that they skip, and the leaps that they make. When your expertise is effortless and automatic, you have a hard time breaking your skill down into component parts, which makes it nearly impossible to create good resources for beginners. So I'm going to consider people who want to learn to program as off-topic for today and focus on people who are already programmers. So once you've successfully completed the Go tour, the next suggested step is to read the language spec. So what could possibly go wrong? Have you ever read the list of ingredients of a Twinkie? I can cook an egg. I can bake bread from scratch. I have a degree in molecular biology and biological chemistry. I know what pretty much all of those things are. I clearly do not know enough cooking or chemistry to turn this into a spongy food-like substance. When I first read the language spec, I knew almost all of the words. I was unable to extract meaning. You could say that I was lacking a foundation, but it would be more accurate to say that I was lacking a map. We don't build knowledge from the ground up, brick by brick. Knowledge lives in our brains as nodes, as graphs, as nodes and edges. We learn by discerning patterns, by connecting new information to our existing knowledge structures. And in the beginning, learning is incredibly slow. Our mental maps are sparse, they're meager. A single node, when it's unconnected to anything, is just a lonely piece of data. It's not information. It's not knowledge. It's meaningless. The more extensive our graph is, the easier it is to map knowledge into old structures, to connect new nodes, to connect old nodes in new ways. And for someone who has a lot of knowledge about language design, reading a single phrase in the Go language spec will light up entire areas of their knowledge map. It'll travel down a bunch of edges, it'll hit a bunch of relevant nodes, and it will create meaning. My mental map of programming language design is practically non-existent. Reading the language spec was an exercise in feeling stupid and inadequate. Now, in retrospect, I don't think anyone meant to suggest that you can only be a Go programmer if you know what extended Bacchus NOR form notation is. The spec is a detailed, formal document. It's intended for language implementers, and you don't have to be a language implementer in order to be productive using Go. All right, so you've done the introductory stuff, but you really want to learn Go, so you need to write a lot of code. What could possibly go wrong? Let's talk about practice. Practice is an interesting thing. It's neither work nor play. We don't do it to be productive, and we don't do it because it's fun. Because if you're doing it right, it's almost never fun. Often people think that they're practicing when they're not. I can't tell you how many amateur musicians I know who think they're practicing when they're playing stuff they already know over and over again. If you want to improve, you need to get out of your comfort zone, but not so far out of your comfort zone that your output is erratic. There's a sweet spot just beyond your comfort zone where your skill barely overlaps with the challenge. And this is where you learn. A lot of people also believe that they're practicing when what they're doing is futzing around aimlessly. Effective practice is focused. You need to have clear goals, and you need a plan for achieving them. You need a way to monitor your progress. This idea that you can learn Go by writing a lot of code fails at every single part of being effective practice. It doesn't specify any goals. There's no plan for what code to write. There's absolutely no feedback mechanism. At best, you will flounder around and accidentally learn something. At worst, you'll put in a ton of effort, and all you'll get out of it is a mountain of misconceptions and a truckload of bad habits. Motivation relies on having a good plan. You need to think that the plan works, and you need to believe that you can successfully execute it. And our general recommendations for how to learn Go are not a great plan. They're unlikely to sustain motivation particularly well. That said, this plan totally works for some people. I'm going to go out on a limb and guess that these recommendations are absolutely fine for people who have deep expertise in programming. And that expertise might come from studying computer science at university or from years and years of experience across lots of different languages and a broad range of technical domains. Where we don't quite do as well is for developers who are self-taught and who have worked exclusively in scripting languages, developing web applications. Another group that we probably fail to serve well is developers who came into the industry through an intensive 3 to 6 month developer training program. The Go documentation and Go resources are outstanding, and they also assume a certain type of knowledge and experience that a lot of developers simply don't have. Now, I'm not saying that it's okay to be a programmer and not know fundamental computer science-y things. I'm saying that it's okay to be a programmer and not know them yet. There really is no one-size-fits-all when it comes to learning. I once worked with a guy who teaches people how to program. He's a great instructor. He's fun, charismatic, engaging. His teaching strategy, however, was basically to throw people in the deep end. Now, this worked for some people. They felt exhilarated and excited. They soaked up as much as they could. Every once in a while they'd come up spluttering, but they learned. Others felt that same adrenaline, but to them it wasn't excitement. It was terror. It was a kick in the guts, and they didn't learn. I tried convincing this instructor that we should build a curriculum that consisted of systematic, itty-bitty steps, lots and lots of exercises, one fundamental idea after another, start with isolated skills and then slowly combine them step by step, test by test. And it sounds logical, right? He hated the idea. Hated it. This is a revelation to me. Turns out, if you try to teach him using tiny, systematic steps, he gets so bored that he completely checks out. He can't do it. He needs that excitement to hold his interest. His natural inclination was therefore to throw everyone else in the deep end too. Now, I'm at the far end of that scale in the other direction. I once spent the entire summer working my way through a university textbook full of trust problems. I wasn't even a student at the time. I just enjoyed this challenge, got this little burst of pleasure every time I solved a problem. If you throw me in the deep end, I will flail around unproductively. But give me a slog, a tedious slog of incremental exercises that culminate in mastery, and I will love you forever. So I want to make a few suggestions that might help lower the barrier to entry in Go for some people, with the full understanding that people learn differently and nothing will be appropriate for everyone. The first thing I'd like to suggest is that we curate a rich set of exercises that help people develop fluency in the low-level component skills of writing Go. The Language Hunters website defines fluency as what you can say when you're woken up in the middle of the night with a flashlight in your face. Fluency is about speed and effort. When we start out, we do things deliberately, slowly, and with a lot of effort. As we gain proficiency, the paths in our brain that are responsible for that skill are optimized, and the skill becomes automated, and we process quickly and effortlessly. One of the really interesting things about Language Hunters is that they focus on the idea that you can be fluent even at a low level of proficiency. And so they've got this scale, proficiency scale, that they call Travels with Charlie. At level 1, we're Tarzan at the party. At level 2, we can ask all of the necessary questions to get ourselves to the party and understand the answers. At level 3, we can run a retrospective about the party. And at level 4, we can have complex conversations that include social, economic, and political topics. If you develop fluency in simpler, lower-level skills, you free up attention, which can then be put to good use, developing a higher level of proficiency. I've been working with a handful of people for the past couple of years to try to develop toy problems in Go for exorcism.io, which is a site that gives you practice problems in a bunch of different languages. And the idea is that you submit your solution to a toy problem, and people can give you feedback, and then you iterate. The first exercise after Hello World is asking you to write a function that computes whether or not a year is a leap year. So we have leap years on Earth because it doesn't take exactly 365 days to make the trip around the sun. Every 4 years, we adjust. But we over-adjust a little bit. So every 100 years, we skip the leap year, and then we're still a little bit off, so every 400 years, we don't skip the leap year after all. Now, this is kind of complicated, but it does boil down to a fairly straightforward bit of Boolean logic. On exorcism, we do see this solution a fair amount, but overwhelmingly, we also see solutions which are great excuses to talk about conventions and idioms in Go, to talk about language features, and talk about basic design principles like simplicity and abstractions and naming. In this example, I would point to Effective Go's recommendation to skip the else if you're returning from within the true block. A lot of people really like the switch statement for this problem. I don't know, switching on a Boolean to return a Boolean isn't how I typically see switch statements used. And here it's even worse because they've got a named result parameter that they're using, so they've got even more indirection. They're evaluating a Boolean so that they can assign a Boolean temporary variable so that they can return it later with a naked return. There's a lot to talk about here. We can also talk about zero values. The isLeap variable has a zero value of false, making the default case superfluous. Sometimes they don't find the modulo operator right off the bat, and so they end up importing math, which usually means that we get to talk about how constants are untyped in Go. In terms of style, I'd probably also point out here that typically long lines are preferred over broken lines in Go. I had to make the font size smaller on this one to fit it on the slide. The important part is this bit here. This is great. We can talk about the rewrite flag for GoFumped. And this simplifies the expression to this, which is still unnecessarily complex. So now we can suggest that they go investigate the concept of truth tables. It's really good. Some people, bless their hearts, do everything they can to make things as readable as possible. Now, I'm a Rubyist. I empathize. Let me collapse some of those helper functions. So all of these helper functions give us a lot to talk about. First of all, we can talk about abstractions and naming. Since they're all exported, we can talk about exported, unexported. Since the compiler will inline them, we can talk about compiler optimizations. Also, in the divisible by function, we can point out that both parameters have the same type, and so the signature can be simplified. And this goes on and on and on. And when they finally get to something reasonable, I point them to the section about commenting in effective Go, which people then proceed to not read very carefully. And sometimes we'll get a comment that restates the signature, which is great. So now we can talk about documentation tools and how they're used. And then we'll get a comment that kind of restates the function signature, but in English. And then I go tell them to read some of the documentation for the standard library functions, because seriously, the Go project gets documentation right. They not only give you a great high-level summary of what the function does, but often the comment will provide important context that you can't get from just reading the function. And they'll also give you warnings about gotchas. In the case of leap years, this is all a bit overkill. But commenting is hard to get right, and I think it's worth practicing it, even with leap years. And there are things we can tell the reader here that are not explicit in the code itself. So that's my first suggestion to lowering the barrier to entry to learning Go. Help people develop fluency with the basic syntax of the language by giving them toy exercises to solve. The goal here is to have enough exercises available that people could solve a toy problem even if they're woken up in the middle of the night with a flashlight in their face, and that they'd solve it using more or less idiomatic Go. Notice that with the toy exercise, even if you get all of the tests working, there's no guarantee that you learned anything about Go. You need some form of feedback. Now, this feedback could be automated. There's a lot of pure linting here. Some things can be detected using the AST, but bots don't make very good mentors. So one of the things that we can do to dramatically improve people's trajectory as they're learning the language is to provide personalized feedback. So go to a meetup, offer to pair with someone, offer to give someone a little bit of feedback on their code. A little bit of mentorship goes a long way. My second suggestion is to deliberately map out important computer science topics and then create problem sets and exercises in Go that help teach those concepts. So just because someone knows what a channel is doesn't mean that they can use it. And just because someone is able to write code that uses channels doesn't mean that they know when it's appropriate to use them. And again, I'd favor trivial domains. It's not that real-world domains are particularly scary, but they're often a little bit abstract and hard to visualize. And it can be helpful to remove incidental complexity and translate more abstract problems into concrete things, like short-order cooks, or Santa's workers, or tourists doing touristy things. So my third suggestion is to make up exercises that use real-world problem domains and then provide a code base as a scaffold. So for example, here we've got a command line client that talks to the Pokemon API using just the standard library components, and now change it to use the SBF13 Cobra library. Or here's a Markov chain generator, tweak it so that it gets tweets from the Twitter API, and now change it to submit the output of the Markov chain back to Twitter. So this sort of thing will allow people to gain familiarity with the patterns and the practices and the technologies, all without needing to know everything up front. Their mental map of the language will grow organically. My suggestions are heavily weighted towards exercises rather than screencasts and the like, and this is deliberate. Skill develops when we produce, not when we consume. If you solve problems in Go on a regular basis, I'd ask that you keep these ideas at the back of your mind. Identify small pieces of the problems that you're working on that could be turned into one of these types of exercises. A toy problem that people can use to gain fluency in the basic language syntax, or an exercise that helps teach a fundamental programming concept, or an exercise that provides a scaffold for practicing real-world techniques. Bridging the gap in this way will make it easier for us to make recommendations that are suited to the people and the knowledge and the expertise of those people who are learning Go. They will be able to construct an actionable plan that they believe that they can execute. And they'll join us in this community that we've invested so much of our time and our careers in. Thank you.